Hi, today we'll be doing a linear search and binary search algorithm. So we'll be doing the searching and sorting part of data structures. We won't be testing all the codes because the recursion codes take like an hour to 2 hours, or probably an hour to 2 hours to just do the recursive part. So we'll try to explain how to do it. You can't really do it in the debugger because it doesn't really show you the paths that you took. You have to do it on paper and like draw arrows and stuff. It's kind of confusing. So I'll try to describe how to go through it. Recursion itself, it can be complicated. It's probably the hardest part of coding because you have to. It doesn't really tell you what the debugger doesn't really tell you what's going on. But anyways, we'll go over that later. So we'll start with linear search. So if it's easy, we can discuss it. So we'll just create a class here called linear search. And we'll be using generics again. So public static of generic type T. Actually, no, sorry. Public class first. We can just have one search class. So maybe we can refactor this. Rename. We can just call it search.java. Refactor that. So here we'll have public class search of generic type T. Then we can put our method in this class. So we'll just do some doc here. So search is the specified array of objects using a linear search. I don't think you actually, well, I guess it does take an array, but you can do it without an array as well. Search is a specified array of objects using a linear search algorithm. At param data, the array to be searched. At param min, the integer representation of the minimum value. Then at param max, the integer representation of the maximum value. And at return, returns true if the desired element is found. So just on another note, so what is searching? So searching is searching data for a certain value. The exact value, the exact definition, I'll try to upload that after. We'll do some notes on it. But basically you're just searching a pool of data. I think there's a definition I have here. Searching is a process of finding a target element among a group of items, which is, the group of items is known as the search pool, or determining that it isn't there. So this requires repetitively comparing the target to candidates in the search pool. So an efficient search performs no more comparisons than it has to. So we'll do some notes on algorithm analysis. You want it to be efficient, meaning fast. So you want to use as less code as possible, and the most efficient code. You don't want to keep looping through something 100 times when you can loop through it just once. Stuff like that. Because if you're making big software, it's going to slow that down. So all that stuff comes into factor with stuff like that. So we'll just go with this. We'll do the method linear search of public static of generic type T Boolean linear search. These method headers are a little bit different than what we usually do. So it takes a T array data int min and int max T target. I'll try to explain it in the notes, but we're going to put a generic method header as well with a generic type. So after that we'll just do the method. So int index points to min, boolean found points to false, while not found and index is less than equal to max, then found equals data of index array index dot equals target. Then here we'll increment index with index plus plus, and then we'll return found. So while not found, so if it's asking for while found, then it's asking for if found is equal to true. So if not found, then that means if found is equal to false. Or sorry, false. So they never really explained that to me, but just through searching around and testing, so just found means if they say while found, that means if while found is true. But if they're saying while not found, that's just opposite, so that means while found is false, I believe. We can test that, or you can test it on your own. So we're just going to need to create an array, put in the minimum of the array, put in the maximum of the array, and then put the target we're looking for. So we can try that here just to test one out. So we can, it's a static method as well, so we'll just call the class. We don't have to create an object for that. So we'll just call it search dot linear search, like that, for a static method. So it's going to take an array, so actually first we'll have to create an array. So we'll say takes a T array, so a generic array I guess, so an object array, integer array equals a new integer array, let's just say of 5 elements. Or we could have we could do that, or we could do this. We could do this way too, with elements like that, but we could just say array of index 0 equals 0 or 1, array of index 1 equals 2, array of index 2 equals 3. Could have used a for loop for this as well, but that's okay. Array of index 3 equals 4, an array of index 4 equals 5. So here we'll say search.linear search. This should work. It'll take an array, then it'll take the min, which is 1, max is 5, and we'll say we're looking for 3. So we'll just run it to see if it works. Save and run. You can save with Control S if you don't know. So it didn't really do anything. It returns a boolean, so we could system.out. .print line and put that all in the print. Should work. Run it again. It should say true. Okay, so it did work. We can delete the print, and we can just have a look at the method again. So we can step into it, why not? It's not a recursive method, so I'll show you why recursive methods are hard. Not everyone's hard, but some of them are just really long. I don't know if that's the correct lingo, but I just call it passes. So every time you call a recursive method, it's going to call itself and go back to the top. And you're going to have to set a pointer, like you're going to have to write it on paper where it called that method. And once you finish that path, and if you go into a second path, some of them have like 8 passes, so you're going through it 8 times. And then when you finish that method, it goes to the 7th pass, and when you finish completing that one, it goes back to the 6th pass. So it's really it's kind of confusing. Like you have to, doing a recursive method requires like several pages of paper. You kind of just have to play with it. I think doing those, some of them, and maybe some other ones in this course, some of them took me like 2 hours to do. To just go through it with a small array like this. So we'll try that after. Like I'll show you how to do it. I'll try to show you or explain how to do it. So we'll do. So yeah, we're doing search.linear search. We passed in the array minimum, max, and target. So we have our array here. It has the elements 1 to 5, indexes 0 to 4. That's it. It doesn't tell us a max. It should, but it doesn't. We'll step in. Okay, now it does. So let's make that smaller a little bit. So public static of generic type T Boolean linear search. We've gone through the parameters. So we're setting int index equal to min, so index will equal to 1. So you can step in. Index is equal to 1. Boolean found is set to false. Step in or step over. Found is set to false. So while not found, so that's asking while found is equal to false, which is true, so it's saying true. And index, which is 1, is less than or equal to max, so is 1 less than or equal to 5. It is, so it's true. So we'll step in. Found points to data of index index. So index is 1. Found points to data of index 1. So we'll look in our array of data array. We'll look at the index which is 1. So we'll look at here 1. So it should be 2. Is that right? I don't know why they skipped the first one. Min, okay. So found points to data of array index. So data of array index is 2. Found equals to. Okay, so they're saying this 2 because I think the equals returns true or false. So does 2, because index, we're putting a 1 in here. Putting a 1, so we're going to index 1, and the index 1 is the value 2, so does the value 2. If you're doing it on paper, you can cross that out and put a 2. So then it says 2 dot equals target, which our target is 3. So does 2 dot equal 3, it's false. So found equals to false, index plus plus, it should be false still. There's false there, I highlighted it. Still false, index plus plus. Index is now 2. So while found, let's turn the other screen off, super bright. Okay, so while found equals to false still, which is true, while not found, which means false. You can also put found equal to false and index is less than equal to max. It's up to you. But a lot of languages support this representation. Actually, they support both. So while not found, so found is equal to false, and index is less than or equal to max, so is index less than or equal to max. 2 is less than or equal to 5. That's true. So step in, we'll move to the while loop to this part. So found points to data of array index, which is now 2, so index 2 of the array equals to 3, so you can cross that off and put a 3 there. Or you can imagine it, 3 dot equals target, which is 3. So does 3 equal the target 3? It does, so found should become true. There's found there in our variables. We'll step in. It's now true, index plus plus, index equals to 3. Well, found is equal to false, that's true, because now found is equal to true. So it should skip out of the loop to return found. So found is equal to true, return. So it should return true if we printed it. And that's all. So that one's pretty easy. Maybe some tricks and stuff you have to practice. The generic type it returns, it's kind of a tricky thing, like it's not even returning a generic type. I think this is the only time I've ever seen these kind of methods. Because usually you can already input, I think, T parameters. It returns a boolean, but it wasn't even of type T, so it could just be a way to set up the method a different approach that we're using generic, so we'll just decide to tag a generic to before the return type. I think there's a definition here somewhere. Generic methods. A class that works on a generic method must be instantiated. Since our methods will be static, we'll define each method to be a generic method. Generic method header contains a generic type before the return type method, so it's saying that we need to because it's static. So if we take this, will we get an error? We can stop and run it to see. Okay, so you have to put that, I guess, if you're maybe from the older version of Java, one of the older versions. It says you have to, you can't reference a non-static type variable T. So Java non-static type variable T cannot reference from a static context. So I suppose that's why, because it's static, we have to put the type T since we're using generics. Maybe that's the only thing, it doesn't really have to be any more complicated than that. So that should be fine. They may get a little harder than this though, so we'll have a look. So binary search, sorry, did we do that one? No. So binary search, I'll try to go over these in the notes, because it's kind of a lot to explain each of these and code them. So if you don't know what it is, you can look it up on Google. It is recursive. This one is recursive. So that means it could be a long code, a long test. So we'll just write some doc here. Searches a specified array of objects using a binary search algorithm. Param data, the array to be searched. Param in the integer representation of the minimum value. Param max, the integer representation of the maximum value. Representation. Don't really need to put that much for that. Just put the max value. It's funny how they explain small things like that in this book, but never like something actually important. So at param target, the element being searched for, then at return true if the desired element is found. So returns true again if the element is found, so it should be a Boolean method again. I guess we're going to be using the comparable method, but we're not the compare to. We're not going to override it. So here we'll say public static of type T extends comparable of generic type T. It's a little complicated. Do we have to implement comparable? I spell it wrong. So T extends comparable Boolean. Binary search takes a T array data again. Int min, int max, T target. So again, you don't really need to worry about that. That's just the return type. So it's just saying it's a generic type and extends comparable of generic type T. It'll all come into place if you're learning generics. You'll be writing them yourself and you won't even know how you did it. That's what kind of happened to me. Like when it's more complicated like that, just keep coding and eventually you'll get it. It's kind of hard to explain. Other than it's just a type T. Like there's an actual definition, but that's even more confusing. Just think if there's a T here, usually, like what we did before up here, there's just a T here. But instead we're saying, okay, this T extends comparable interface and it's of generic type T. That's all it is. You can just think there's a T here and it extends comparable. That's all it is, really. You don't even have to worry about it. You can just remember that this method returns a Boolean and it takes these parameters, which of type T, which we've seen. We've used type T parameters, like we passed in T element and stuff, T target. It's the same. The reason why it's T is because we don't know what type it's going to be. If it's going to be an integer or a string, we don't know. So that's why we do T array, T. Because when we instantiate our array in main, excuse me, we created an integer, but we could have also done a string, right? We could have changed this to string, and it still would have worked. That's the whole point of generics. That's the whole point of this T, is that we can either use strings or integers on the fly. We don't have to say it's an int array and a string array. We can change them up as we need to. That's the point of it. And it works either way, you won't know what it is. So we'll just do a boolean here, variable found equals to false. Let's make this bigger a little bit. So int midpoint equals to min plus max divided by 2. If data of array index midpoint dot compare to target is equal to 0, which means that if they're the same, because compare to returns a 0 if the elements are the same or the objects are the same. Then here we'll put found is equal to true. We'll do an else if. Else if data of midpoint honestly, it's kind of boring, this stuff. It's just like boring math stuff. Nothing exciting. But it's part of data structures, you have to do it. It's honestly just looking for a bunch of values. That's it. It is pretty boring, to be honest. So it's just else if data of midpoint dot compare to target is greater than 0. It's good practice though, like practice of the conditionals and stuff, and generics. So if min is less than or equal to midpoint minus 1, then found points to, here's the recursion part, binary search, it calls itself, and it passes in the same, actually not the same. Here for max, the max is going to be midpoint minus 1, that's all that it means. You can see it, I don't know if you can see that, but it highlights max here, it's writing max. And it's saying the max is midpoint minus 1. So else if data of array index midpoint dot compare to target is greater than 0. If min is less than or equal to midpoint minus 1, found points to binary search of the parameters data min and midpoint minus 1, which is max, which is a max for this one, and target. Then here we'll say else if midpoint, else if midpoint plus 1 is less than or equal to max. So if the midpoint plus 1 is less than or equal to max, then point found to binary search, again another recursive method call. Max and target. So imagine if you're searching 10 values. It's not that much, but you could be going through these loops for a long time. These recursion loops. Like there could be like 12 passes or even more. so it could get complicated. So else if midpoint plus 1 is less than or equal to max found points to binary search of the parameter data midpoint plus 1. So you can see the min and the max are switched here. These are opposite, and 1 minus is 1 and 1 adds 1. Return found, so that should be it. We can test it. I don't know if we'll do the whole thing. So we can comment that out. So we'll say search.binary search. We'll pass in array. What else does it take? A min, max, and target, so we can do the same thing. Min, max, and target 1, 3, 5. We'll just run it. Might take longer because there's recursion to run. Nope, maybe not. So we'll just debug it. So it's saying we're passing that, or we're calling this method, or passing that array these parameters. We'll step in. Found is set to false. Midpoint is set to min, which is 1 plus 5 divided by 2, which is 3. If data of array index midpoint, that's a lucky one because we already found it. Was just a first time try we found it, so we'll change the value. If data of midpoint, if data of array index midpoint, which is 3, dot compare to target, so it's already found it. Oh, I should have. Midpoint is 3. Our target is 3. That should have worked. Wait a sec. We'll debug that again. So min, max, and target. Unless I missed something. Boolean found points to false. If midpoint equals to min plus max, 1 plus 5 divided by 2. Oh, it's divided by 2. What is the midpoint then? Because it might do some decimal division. Okay, it is 3. If data, oh, okay, I think I know why. Because it's saying if the data of array index midpoint 0, 1, 2, 3, so it's 4, so not actually 3. I think if we would have put array index 0 is equal to 0, array index 1 is equal to 1, then it would have found it on the first time. So what it's saying is if data of array index midpoint, if data of array index midpoint, which is 3, so if data of array index 3, which is 4 dot compare to target, which is 3. So you can just say 4 dot compare to 3 is equal to 0. Well, are they equal? It's not. So it's false. It's going to skip to this else if. If data of array index midpoint, which is 3. So 4 dot compare to target is greater than or equal to 0. So it's 4 dot compare to 3 greater than is 4 dot compare to 3 is 4 greater than 3. It is, because if the first one's greater than the last one, it should return a 1, which is greater than 0, so it should be true. So if min is less than, if min, which is 1, is less than or equal to midpoint, which is 3, minus 1, which is 2, so 1 less than or equal to 3 minus 1, so it's 1 less than or equal to 2, it's true. Then it's going to call found of binary search. It's going to pass in it's going to call binary. It's going to say found is set to, because this method returns a boolean, so it's going to return a true or false. So it's going to say found is going to return either true or false depending on this method call. So this method call is going to return true or false, and that found is going to be set to either the true or the false part of this method. So it's just going to be this method is going to be return true or false, and this found is going to either be true or false. So that's what it's saying. So it's saying, okay, found point to, and then call this method, and when you're done calling that method, it's either true or if it's false, and then we can continue down here. But for that to happen, it's going to be more complicated. So what it's going to do is going to call binary search with the data in the data array, the min, which is going to, the data array and min are going to stay the same parameters, so it's just going to be the T array data, which is that one, ARR. For array, min is going to be the same, 1. Max is going to change from 5. It's going to be 3. So the 3 minus 1. So it's going to be 2. Max is going to be 2. So it's going to be the array. Min is going to be 1. Max should be 2. And target is going to be 3. So it's going to call the same method with those parameters. So it's going to call here, and it's going to come back up. It's going to start back up there, or maybe here. And the parameters are going to change. So the way to do this is to take a pen and paper. Here's the way I did it, and write first pass here. I don't know if that's the correct way to do it. This is what I do. I put a first pass here, and what's happened is we're going to call the method. So step in is going to go back up here. So now this is where our first recursive, you can put recursive pass, recursive pass. So when this method's done, when this method call is done, we're going to finish here, and that's going to return, remember, true or false. And after that, we're going to skip else if to return found, because I don't think this one's going to hit, because it's if, else if, or this, else if. So right now we're here, and again, this IDE isn't really designed for recursive methods. It should have a better system. Maybe it could put a flag here or something with an arrow and put like recursive pass 1 or something. But it doesn't. So now we're at the top. It's going to set found to, again, we're not going to go through all of them because it's going to take a long time. I'll just show you how to, we'll try to do this one here. Instead of pen and paper, we'll try to do it on just by typing. Because then you might have to erase them as well and like write them again, so I'll try to show you. So boolean found points to false. Midpoint, what was our parameters? So it tells us, oh yeah, you should maybe write the parameters down beside this too, just in case you forget what the parameters are somewhere. Maybe we can put here like we call binary search data min. We'll say max equals to midpoint minus 1 and target, and then we can maybe put some brackets here, put like the array, the min is 1, max was, original midpoint was 3, minus 1 should be 2. So we'll just put where should I put that? Maybe here. And target stays the same as 3. So then when we come back here, we know, we can check if we get lost. So midpoint is now equal to Well, what's our min? It's 1. Our max is 2. So 1 plus 2, which is 3, divided by 2. I think that it, with the division in Java, just does whole numbers. So it'll tell us what it is. Midpoint is 1. If data of array index midpoint, which is 1, array index 1, which is 2, sorry, 2 dot compare to 3 is equal to 0, well that's false, because they're not the same. Else if data of array index midpoint, which is 1, array index 1, so 2 dot compare to 3 is greater than 0, also false, I believe. So last condition. It's either the same, it's equal, less than, or greater than. So now we're on the last one, greater than, or sorry, less than. So if midpoint, which is 1 plus 1, so it's 2, is less than or equal to 2. It is less than or equal to, it's equal to. Then again, do another recursive path. So now this is the tricky part, because we're doing a recursive call in a recursive call. That's the problem. So this is where it can get complicated, and I'll try to explain it. So now we would take that first and put a second here, because when we're done that, we're going to put second recursive path, the parameters, and hopefully that'll be the last one. Then when that finishes, we have to continue with the method call, so return found. So it's going to return found for, so yeah, we'll go through it. That's where we can get in. Imagine if you have 8 passes. That's what I'm saying, or even more. 8 to 12 passes. I haven't seen anything more than that. But I think I did see a method with 8 passes in this. I think it was one of these algorithms, the searching ones or the sorting ones. So that can take hours to do. So for that, so what we're going to do is we're going to say second recursive pass. I never seen anybody do this on YouTube. I haven't seen any videos. Maybe they have a better method than me. But personally, I haven't seen anything. When I was learning it, I just learned it myself. I'd never really looked at anything. Maybe here and there for a few small things, but so we'll just do so second recursive pass. So again, it's going to return true or false. We don't need to put that because we know. And we'll put the parameters. So it's going to call binary search data array. We know that we don't need to put that. So min is going to be. So what do we say? We said min equals to, or max equals to. Okay, so we'll say min equals to midpoint plus 1. And we'll say that is midpoint plus 1, so 2, I think. The max, I think take the current max. Take the current max as well. At the current time, don't take the one we started with. It should be correct. So take 2. Where are we? Here. Max equals to 2. We're going to see when we call it. And then target equals to 3. Should be right. So we'll jump into it, step in. So where we correct, min is equal to 2. No, min is equal to 1. That's right. Min is equal to 1. No, that's not right. Min is midpoint plus 1. Okay, now it's not going to tell us what our variables were. Midpoint plus 1. What was our mid? It was 1. Yeah, it was 1. Maybe I just made a mistake. Was it? Yeah, it was 1 plus 1. Might have. Isn't that right? Oh no, yeah, that's correct. I have 2 here. I'm looking at this one, I think. So 2 and 2 and 3. We're correct. I was looking at this one here. Unless I was looking at the wrong place altogether. Second recursive path, binary search, passing in data. Min is equal to midpoint plus 1, which is 2. We have that there. Max is equal to 2. And target is equal to 3, so it should be correct. And now we're at the top again, so we'll go through it. We'll finish this one. It's probably already taking like 20 minutes, but when we finish that method, hopefully we don't have a third recursive path. It's going to return again true or false. So maybe we can just put here T or F. Returns TF. Just so that we don't forget. Put here TF too so we can see it without going too far. So now we're here. Boolean found is going to be set to false. Midpoint is set to min plus 1. Min, which is 2, plus max, which is 2. So 4 divided by 2 should just be 2. Midpoint should be 2 right there. If data of array so data is referencing our array. So if data of array index, that's what when I say array index, I mean between these square brackets. If data of array index midpoint, so we look at 2, so midpoint's equal to 2, so we put a 2 in here. So if data of array index 2, so we go to 2, we get a 3. 3 dot compare to target, which is 3, is equal to 0. It should return true. Returns true. So found is set to true. So we solved the method, so it's kind of like, well, what's going to happen now? We found it. So we're just going to follow the recursion. So we're going to take a true here. We're just going to, so after that, this whole thing, we can even cross it off in our pen. That's why I said pen and paper is good. But we're going to take that whole line here and just put a true. Or we can put a equals. We can take this line out here and we can put a true. So found is equal to true. We'll step in. So here, what happened is that it actually went here. So we're going to say this whole thing was set to true. So this can happen once it solves it. It will just be passing true. I think that's what's going to happen here. So it's going to take true. So it's going to say, okay, this recursive call found return true. So now found is equal to true. Now it's saying return found. So we're going to return true for this one as well. Should we go back there and should come up here? Well, what it really does is just come here. So hopefully I'm not confusing anyone. So we're at this pass, we completed it, then we have to transfer to this line, the next line. So we're going to return found is true, step in, or step in. Then after that it actually went here, went to this line. Then it said, okay, found is equal to return true here. We're going to take this whole bunch of crap and we're going to put true here. So we have true. Then that line finished. Now we're here. So then it's going to call again another recursive call. So we'll have to, since we know that it returned this second recursive pass, our old one returned true, we're going to return true. So else if midpoint, which is, oh yeah, the data, the variables are going to change too. That can be tricky. So you're going to have to either do it in the debugger, maybe do it like we're doing it now, because I think keeping track, because every time we did a pass, notice how the variables changed. The variables change every time, like max was 2, min was 2, then another time it was 3. It's going to change, so you may want to put your current variable iteration in there, so we can, like beside there, you can take your fields and put min equals whatever, max equals to whatever at the current time, and maybe the changes. Or you can maybe just do it like this, because it'll just keep track of it for you. Because they did change. Targets stay the same, but min and max and midpoint changed. So now it's going to call again another recursive call, I believe, because if midpoint plus 1, so midpoint, which is 1, plus 1, which is 2. So is 2 less than or equal to 2? It's equal to. So that's true. So it's going to go to this line, found equals binary search. So it's going to do another recursive call. And since our first and second, so we had a first recursive pass and a second recursive pass. So since those were completed, we can again start at first recursive pass. First recursive path. Or we can just do first, or just, yeah, first recursive pass, and then we'll put here binary search. So we're going to call binary search again. We're going to pass in data, min, which is, so min is equal to midpoint plus 1. So midpoint is 1. So 1 plus 1, which is 2, I think, because it says midpoint, which is 1, plus 1. So min should be 2. Max should be 2. Where are we? Here. Okay, so then max here is equal to 2. And then we'll say midpoint is equal to, sorry, yeah, that's fine. 2, 2, and then our target's 3. Should stay the same. We've already found it, so it's kind of a silly algorithm. So then here we'll say we're doing that, and we can note if you really want to, we can note the variables at the time. You can say like variables, vars, short for variables, current time. So you could be like min equals 1. If you're doing it on paper, max equals 2, target equals 3. That'll help you keep track when you finish your pass. When you come back and put a true here, you can keep your variables at the time to continue. I think that's what I was doing before. But you can also just use you can step through with the debugger. Because if you're using an IDE on a test, hopefully they don't give you a recursive method, because it'll take a lot of time. But if you're just practicing, if you're allowed to use your computer, then I try to do it in here. It seems easier, because this is the first time I'm doing it on an IDE. Usually I just do it on paper. Perhaps it cuts the time in half, because you don't have to figure out what your variables were at the time. So right now we have our 1, 2, 3, min, max, target, and don't forget midpoint. We'll just put maybe MP for midpoint equals 1. So we're going to step into that method, and again it's going to return true or false, so I'll put here TF returns true or false. We know what it means, so we'll call it step in. So it just passed through it. Okay, perhaps that was just the method that was the second pass then. It just returned, no, that was this one. So it should have been if midpoint found is equal to, maybe because we've already found it, then it's just returning true, perhaps. That's what I think. So maybe this algorithm's just a little bit, it could be the IDE, because we should have went here, then maybe come up here, then midpoint equals to min plus max, which what was it? 1 plus 2 divided by 2, 3 divided by 2. I think because we've already found it, perhaps it's just gonna skip through. Or maybe it's saying that it's gonna return true anyways, because it's already done that. Because we've already done that one where it's with those numbers. So perhaps it's just gonna return true for us. You can go through it. It probably will. Because it's gonna call again. So if we do midpoint, which is 1 plus 2, min is 2, max is 2, okay. Uh, 2 plus, okay, so 4 divided by 2. So min plus max, just double check here. Min is 2, max is 2, so it should be, we should get a 2 for midpoint. If data of array mid, okay, I think that's what happened here. So if data of array index midpoint, which is, so it looks like the IDE skips some stuff here and there. It does that occasionally. So it's saying if data of array index midpoint, so if we take these parameters, 2 and 2, we should get 2 plus 2, which is 4, divided by 2, which is 2. So if data of array index midpoint, which is 2, index 2, which is the value 3, so if 3 dot compare to target, which is 3, equals to 0, it's equal, they're the same. That should found equals to true. So this found should return true. So that's why it's saying return true. Because that's what it was asking. Gets return something here. We're saying this is a first recursive pass. Then we're saying, okay, this stuff return true. So we can take that out and just put a true here. I think it skipped that. Or maybe I stepped over it. I thought I did step in. So it just returns true. And then our current variables are min is 1. Or our variables, min is 1, we have them written down. If you're doing it on paper, max is 2. Whoops. Target is 3. So those are the variables that we had. And when we went through this pass, the variables changed. The one we just got true from, when we went through it, the variables had changed. Midpoint was 2, etc., etc. Max was 2, min was 2. They're all 2. Now they've changed back to 1, 2, 3. And returning found, this should be the last return to main. I think that's what it was. Okay, maybe it's just checking here, returns true. it should work. That's the way we should be fine. I'm not sure why it skipped through here. Maybe because it did return true initially, so it's just checking. But that way seems to be fine. It worked. We can just skip to that part at the end. It did work though. So I noticed it did jump up for a sec. My hand just clicked. It was saying that it returns true. But I've solved these on paper. I think I did this on paper. Got the same result, so it should work the same. Sometimes it does that just to bounce back to show that it returned. But how many passes we did? Whoops, no. Don't step over, step in. So step in, step in, step in. So we had a first pass. Then we had the second pass. Then we returned something for the second pass. Then we did a third pass. That's the one we did where we got these. No, is that correct? No, I think that's turned true. Is that it? It seems like we did it right. So we had our, I don't want to do it again, that's the problem. So we had our first pass. We can just write here first pass. Then we stepped in, stepped in, stepped in, stepped in, stepped in, stepped over, stepped in. Then we had our second pass. Sometimes it bounces back just to show that it went there. I think I've experienced that a few times in this IDE. So second pass, we're gonna step in, found, false. Yeah, this is where we were. This is where we had 2 plus. Is this where we were? No. Because I thought there was a third pass that we did. I think it was the same pass, but the same values maybe. So return true for second pass. So that's gonna finish, and we should come back up to this line, which will probably bring us to this one. There we go. Second pass is done. We return true. So I think this is the one that where we had these ones. Okay, I think I know why it bounced up here, to show us that we finished it. I thought we've already did that. So we're here now. If you can remember, we got we did these variables. We stepped in, and that's right. It skipped that one. So we did this. We went through this. We took our 2, 1, min is 1, max is 2. No. So we had 2 and 2. Oh no, I think I deleted it. But it was midpoint. Okay, here we go. Min is midpoint, which is 1, plus 1, so 2. Max was 2. Because we deleted it, because before we had a binary search here with the parameters to take in for the method, right? And I had deleted those. But what it really was I don't really want to write it out again. But what it was midpoint, which was 1, plus 1, which is 2. So min is 2, and max is 2. So when we call that, we went back up here. Because it went up here, then first part is this part of the method. And it said midpoint equals to 2 plus 2. That's what we said, divided by 2, which is 2. If data of array index midpoint, which is 2, equals to 3, so 3 dot compare to target, which is equal to 0, so it's equal, so it returned true. Then this line returns true. Then here we're going to return true for the first pass. So I might have forgot to return something for the first pass. I might have just thought of it in my head that it already returned true. So what it does, it's going to bounce up here, because this here is going to return true. It already did. It skipped that part actually. The IDE itself, IntelliJ, skipped that pass that we just did. That first, I guess we could have called it a third pass. It seemed like a first pass, but we could have called it a third pass. Hopefully I'm not confusing anyone. Because this one is already done. That's why I called it a first pass. I called this one a first pass again when we did it again. But maybe should have just called it a third pass. Actually, maybe a second pass, because we had already completed our second pass. So if we said our second pass returned true, then we would have went here. Then we would have ended up returning true. It would have went up here. Return true. Right? That was done. And then it was done. So it's a little confusing. You might have to go through it a few times. Because the reason why it didn't go up here after the iteration we just finished here was because it either is if, else if, or else if. So if you do it a third time, you should get it. Maybe we can just do a quick step through again. But because that first pass was completed, it's not going to hit this line because it's either else if or else if. So for return true, then just return true. That was the last call, so the last call came from the main method. The original call, perhaps you can call it the original call. Maybe we can just do a quick step through once again. Main. What is happening here? Stop that. Okay, start it. Just try to do an imaginary run here. So original call. Step through, step through, step through. First pass. So it's going to go up to the top with those variables. Step through, step through, step through, step through, second pass. Right? Step into, now second pass. Not true, we don't know what it is. Step in, step up. Step in, step in, step in. What happened there? Okay, so, whoops, why don't I just start that again? I think it went up here, but I skipped it to that return. Just so you guys know 100%. If you already know, that's fine. But we'll just step in, step in. So there's our first pass. Second pass now. Returns true for our second pass. So there we go, returns true. So we had our second pass, then our first pass. That one was skipped. I guess that one was skipped because it was an else if. So now it should just bounce up here and it should be done. Return true, done. So I think we didn't even need to do that one because it was an else if. I think there's a glitch here with the IDE because it actually hovered over this line but it didn't go in. Maybe that's what it should do. Maybe like, because what it really should do is just, no, that's wrong. What it really should do is just hover over this line, check the condition, and if it's not, then return found, because if it's not, it doesn't really need to go into it shouldn't step in, and it didn't. So that's, I think there's a glitch here somewhere. Perhaps the brackets might help. We can see if we maybe put some brackets here. That might change anything. Could be a glitch somewhere. So we'll try running it again just to see if it does the same thing. I'm thinking it's a glitch because we already know we got the answer. We know how it works one way or the other. But sometimes I do see glitches in IntelliJ. So there's our first pass. Second pass. So our second pass was done. It returns true for the, so return true for our second pass. So now it should go up to our first pass. Pass. So now we're here. I don't know why it does that. Maybe could it be because the bracket moved there, but it's not going to hit that because it's already returned. It's already false. Can we try with that? I don't know why I formatted my brackets again. Step in. So this is our original pass, original call. First pass. Second pass. Returns true for our second pass. Now, okay, so return true for our second pass. Then it should come up here. Second pass is done. What it really should do is should have gone to this line, I think. So now we're back at our first pass. We're finishing it. Then it shouldn't really even be checking this one because it was already else if. So now it should just bounce to return true. So it's going to return true. It should bounce up here to check. So it's going to say, okay, we return true for that pass. It doesn't really need to bounce there, but just to say that it did. Maybe for recursion it has a different algorithm. So it's saying, okay, return true for this pass, return true for that path. Overall, we return true from that pass. So we're going to return true to the original pass, which is what it did. So I hope that clears up any confusion, and we will do the sorting algorithms after. So take care.